Hi, welcome to the breadboard. It's the end of the week, so it's time to have another close look at a new product. And what I have for you today is something that will be of quite interest, I think, to a lot of you. And I have several displays from a company called IDE Studio, and these are model called Nextion. They are ranging in sizes from about 2.5 inches up to 7 inches that I have. And I have 3 different models to show you. One of the small one the middle size, and of course a 7-inch one. The really nice thing about these is that they can be programmed very, very easily using a PC-based design tool, and your layouts and active components and backgrounds and graphics and everything else can all be uploaded to the display and work independently of your microcontroller. The microcontroller only needs to send commands and respond to touch events that are sent down to the microcontroller through a serial port. It has a transmit-receive TTL serial port built into the device, and this is what you program it with. And it's also what the Arduino or Raspberry Pi or Launchpad or whatever microcontroller you happen to be using will use to communicate with it. So it is very, very simple to hook up to your device. One of the other nice benefits is that because all of your graphics and layouts and buttons and everything else to do with controlling the screen is all built into the actual controller of the screen, then you don't have to have that overhead to run your display from your microcontroller. So even something like an AT Mega 328 that you find on the Arduino Uno has more than enough horsepower to do a fairly complicated display, because the work it actually has to do is very limited. And let's have a close look now, and I'll show you the 3 displays. And one of them I've already quickly put together a program on it, or at least a graphics with a bit of fake programming behind it to demonstrate what I mean. So let's go have a look. So what I have here is the 7-inch Nextion display, which has a resolution of 800 by 480. It has a resistive touchpad on it and has 65K colors available to it. The ARM7 Cortex processor that's running it runs at 48 megahertz. It's got 16 megs of flash and 3.5K of RAM on here for this. So this is actually probably more powerful than the Arduino over here that's actually driving data to it. The display in the front here is a 3.5-inch display. It is a 480 by 320 display on here. Still has 65K colors, 16 megabytes of flash and 3.5K of RAM, and it is also running an ARM Cortex 48 megahertz processor. So the last display that I have here, which is this one, is a new enhanced model from IDE Studio. It is the NX4024K032, and what this one is a 400 by 240 display. Still has the 65K colors, 16 megabytes of flash and 3.5K of RAM. Its processor is still an ARM Cortex 7 running at 48 megahertz, but it also has 1K of EEPROM on board, that you can save your user your own variables to, and it has 8 GPIO lines, and the GPIO lines are brought out via a ribbon cable in this case to a little daughter board. You could of course build your own daughter boards for other kind of push buttons and things like that if you wanted to. And in this configuration I've got 6 buttons, an LED and a buzzer that is all available and usable by this display. So this is one of the very latest ones that is from IDE Studio and their new lineup of displays. If you go up slightly from the 3.2-inch display, which is what this one is, to the 3.5-inch display, the processor actually jumps up to 108 megahertz. Everything else pretty much stays the same. The resolution obviously goes up as you get bigger displays. This one will go up to a 480 by 320 resolution if you take it up to the 3.5. This particular one is the 400 by 240, as I said. So that's the general overview of these three boards here. They do have a whole range of other sizes. They go from 2.4, 2.8, 3.2, 3.5, 4.3, 5, and 7 inch are all available from IT Studio, and they are actually a very, very good price. And there's no point in me saying how much they are, but they're certainly, the small ones are measured in like under $20. The bigger one is, I can't remember the exact price of that, but I will provide the links to all of these so that you can look it up for your different countries and everything else. But they do make a very economical option for getting a high quality display for your Arduino projects, Raspberry Pi projects, Launchpad, ST Micro. It doesn't really matter what the microcontroller is or the microprocessor is. As long as it's got that serial port, you can actually talk to these displays and have it do something. So going to the first one over here, the big 7-inch one, I've actually put a program onto that, as you can see. Let me just zoom in a little closer to it. I have this Arduino Uno on the left as part of that display. It's actually talking to it through the serial port. These cables at the back here are hooked up to this. I've got 5 volts being supplied to the board from my USB adapter. I have a temperature sensor on here. You've seen this being used before with my Launchpad projects that I was doing last week. This one here, it's a TMP275. So it's it's an I2C temperature sensor. I have it hooked up and being read every second, and having the display updated with the information as I go. So let me just zoom in a little bit on that right there. So what you can see here is, here's the temperature down here being read from that probe, and if I just go put my finger on, you'll see it start to climb up. All right, 30.6, 31, 32, etc. Now I do actually have on here, I have an active graph, a wavetable being shown here as well, and I'm not sure how well you can see. Unfortunately, I got something on there which was generating a little bit too much noise, because I've got a couple of analog inputs that are kind of floating around as well. There's a white line here which is being used to trace the temperature, and I've got a couple of other of the analog inputs just being fed to demonstrate it. But since I brought it out onto my bench here, I've got something that's generating noise and it's picking it up a little bit too much, so I'll have to look at that when I go into actually start detailing programming and everything else for these units in another video. For now, I just want to show you the capabilities of the display, and in this case this noise is not because of the display, it's just my Arduino Uno is picking up on it. So focusing closer on the display here, all it took to actually do this layout was I fired up PowerPoint, and I just did a basic layout in PowerPoint without the active components of the display. So that would be these sliders, okay, on here. They were not on there. They've been added by the design tool. These 6 display text elements, they're showing the values being read, were not part of the base display. Obviously the active part of this wavetable is not, and the temperature here, the active part of that was not. So everything else, the breadboard logo, the text, the big long arrows, and all the background elements, and these 3 buttons were actually put onto the PowerPoint, and then I saved it as a PNG and scaled it to the 800 by 480. I then created another PNG from the same PowerPoint, and what I did was I changed each of the buttons to reflect what I wanted them to look like in their press condition. So if I press the off button right now, you see how it changes, and it effectively has that 3-dimensional effect. That is simply changing 2 different graphics that is being clipped around there from one PowerPoint PNG file to the other one, and the same for the on and the reset. The reset will actually is programmed in the Arduino, that if the Arduino sees the reset button being pushed, it'll reset the watt hours that have accumulated. So if I just do that, you'll see this goes back to 0 and starts counting up again. And just to show you that this is actually completely interacting with the Arduino, let me just zoom that out a little bit. You can see here I have a little purple LED turned on right now, right here. You should be able to see that well enough. And if I press the off button on the display, you can see it turns off the LED. Now obviously that LED could be a MOSFET, it could be a relay, it could be anything you like. In this case, as you can see from this basic layout, I'm slowly building up a power control because I'm long overdue for doing the next stage of my power supply project. So I've been playing around with a few different options for giving it a nice display and putting in some kind of microcontroller in the background to control it. Now I may use this display, I may use a Raspberry Pi, I haven't finally decided yet, but this was just an example I put together fairly quickly to be able to show this working with an Arduino, and it's very, very easy. I'll have a look at the code in a moment. Now literally the only difference between doing the layout for this big 7-inch one and doing it for this little 3.5-inch one or the 2.4-inch one or this new enhanced one is that you tell it what screen size you have in the design tool, and you obviously scale all of your elements appropriately. Outside of that, all of the functionality is pretty much exactly the same. The way that you talk to it, the way that the variables and buttons and text elements are written to is identical for all of them, and it's the same design tool for all of them. So it really is very, very easy to create something that will work on a little display. And if you've got somebody with big chunky fingers and you need a big one, well, you can just get a bigger display, scale your design up, and your code itself on the Uno, it wouldn't care. If I just shrank, in it went into my graphic, the PNG, and shrank this down to a 480 by 240 and dropped it onto one of these other displays, and obviously shrinking the buttons and things like that as well. Outside of what has to go into the display, I wouldn't have to change one thing in my Uno. All right, so that is really, really nice to be able to have that option as well to be designing with. The new display with the enhanced capabilities, that one has extra commands available to it, which allows you to play with the buttons and read the I/O, and they can be inputs or outputs. For example, right now there's a LED on here, and if I push the LED button on here, right, you can see that LED turning on. All right, if I press the buzzer, I've got a cover over the buzzer because it's really noisy. All right, and these other 6 buttons actually get reflected here. I can push them individually here, but they're also coded so that if I push the buttons here, they will also be reflected up on the screen. So you can see it's reading the I/O and interacting with the display here. Now, outside of that, everything on this display is exactly the same as here and here in the way that you code to it and use it and talk to your microcontroller and back from it as well. So that's very, very easy to do. Now, for programming the Uno to use this, there is a Nextion library that is available. The one thing you have to watch out for, which I'll admit I got burned on doing this, is that I was using the hardware serial port to talk to the Nextion, and because the Uno only has one hardware serial port, I was also trying to do some debugging and things like that, and of course you can't do both. There's a protocol for talking to the display, and because I was sending debug commands partway through sending data to the display, it was messing it up, and it actually took me a little while before I realized my stupidity, and I stopped sending the debug commands and everything started working quite happily. Now, the code for this, everything in the Uno, even with its limited resources, is still less than 50%. It's about 47% of the EEPROM to do everything I'm doing here, which is, it's reacting to event handlers from buttons being pressed. It's reading 2 analog channels and sending the data up to the display. It is reading the temperature controller, the TMP275, and sending its values up to the display, and it's doing all of this in less than 50% of its memory. If I was actually trying to drive a display like this through a SPI interface or something else, I just wouldn't be able to do it. I would have to go to an AT Mega or something like that. And talking about AT Megas or other microcontrollers with more than one serial port, of course, when you've got that, you could have 2 displays on there. If you were using software serial, you could have 2, 3, 4 displays. Even though there's a library to help you do your Arduino coding, you don't actually have to use it if you don't want to. You can get a little bit lower level, and it's not too complicated, and actually just do serial write, serial print line, and things like that commands, and you can still make this thing react correctly and receive commands from the display, and you just have to do your normal parsing of the strings that come in the way you would if you were sending it through the USB to the board as well. If you've got the AT Mega as well, you can have your debug going on at the same time as you have your display active, which makes things a little more friendly as well to be programming with. But outside of that, that's these 3 displays, and as I said, there's a huge range, and I'll provide a link to their site. And I think they're really, really good, and the price is very good. They're easy to use, and so here at the PC, and the first thing I wanted to show you was what I used to quickly design the screen layout. So this is PowerPoint, and I just laid out a display here, put my logos in, grabbed some standard graphics, laid it all out, and this is exactly the one I was using. And I saved it, and then I made a copy of it, which has the different buttons on. So if you look as I switch between them, you can see they move a little bit. I probably should have had them better aligned than that, but anyway. And they've obviously, the main thing I was trying to get there was the shading was different. So when I press it and I have a little area set on it, then it flips between the 2 parts of the image and gives the impression of having a 3-dimensional button that's being pressed. The set point, actual, and power areas, you can see here there's no text areas. That's all done within the design tool for the Nextions, and then all these other elements are just part of PowerPoint, and that's it. So all I did within PowerPoint was I just saved them as a PNG, resized them, and then imported them into the Nextion editor. All nice and easy. So let's go to the Nextion editor and have a look in there. So this is the Nextion editor I fired up. This is the latest version that they have available. And this one is version 0.35, and you can get it from IT Studio. I will provide a link to it. And you tell it what display you're using, so you can pick your layouts as well as the device. So you got the basic one, which is what my 7-inch one is. You got the enhanced one, and then there's another one that's going to be coming down the line soon, which is an intelligent enhanced display, but you can't use that one yet. So the enhanced one would be the enhanced display that I have is this 3.2-inch one right here. My 7-inch one that I was working on is this one here with an 800 by 480 display. So you pick your device, you pick how you want to lay a display out. So I want this one horizontal, and you just say OK, and it gives you a blank screen. And then all you need to start doing here is you need to bring in pictures. So down here there's an area for pictures and fonts. So you can just click plus, drag in any pictures that you want to use on your display. And in my case, I went and grabbed the 2 PNGs that were used that you saw before. And I also grabbed in a couple of other elements that I was playing around with. Everything else on here is all built in. Things like waveform, you just click it, it puts one on the screen. This is what I had the wave traces going on to. You just size it the size you want. You can rename it to whatever you want over here, and you can set some of the parameters like how many channels you want to have, up to 4. You can set the background color, whether the grid's on or off, and a few other things. And then that's all you would have to do, and then you can start writing to it. And right here, its initial object name is S0, and you would have to use that when you are sending commands, or its object ID, which in this case is 1 because it's the first device I put on the screen. Other items that are on here, let me just get rid of this. You've got things like standard buttons, and what I did with mine was I laid this over the graphic, and then I told this button to be transparent. So down here for a button, you see this, if you click on these, it gives you help at the bottom here. So this is the background of the button, and right now it's saying a solid color, and you can change the color, but you can also tell it to be a crop image. And what that does is everything that's directly under the button image, when you pick a full screen image, so you come in here and you would pick a background image, will show through that hole. Now, I'm not trying to do a whole design tutorial for the Nextion editor here, so I'm not going to show you how to do all of those things. I will make another video at a later date on actually using the editor and getting how I made that actual panel that I had shown you before. But this is all you really have to do. You just drag these items on, and you lay them out on your screen. So you've got text areas, you've got numerics, you've got buttons, you've got dual state buttons. So it's like you click once, click twice. Variables, gauges, with pointers, and you can replace the pointer with a graphic of your own, and the outside can be a graphic of your own as well, so you can make some nice graphics with this. You can even have a limited animated pictures and things like that as well by using a timer and rapidly selecting different images to have on the screen. And because you're running a 48 megahertz ARM Cortex ARM7 processor, it's got more than enough horsepower to be able to deal with that. And let's go look at the Arduino code now so you can see how easy that is. So here is my Arduino code. Just going to try and make this a little bigger font for you. So the code that I have here, so the first thing that I included was the Nextion.h, which gives us access to the library. And this next area here is declaring all of the objects that I have on the screen that I want to talk to. We'll also have a few more variables for dealing with locally calculating some of the setup, the amps, the volts, the watts, and things like that. Is attaching the event handlers for each of those items up here, what I just showed you, all of these objects. I'm attaching an event handler to them. So that's where I'm doing it here. So the on button, if I press it, it's going to call a method, the on pop callback method. And then you got the off, the volt slider, the amp slider, and a couple of other ones here that just deal with a couple of text boxes, because we've set the display up to send an acknowledgement back to the Arduino when you send a command, just so you know that it's done properly. So this is all just hooking up the event handlers. And then our main loop is actually just this. There's actually not a huge amount to it. And then after that, what we have is a series of callback routines for each of the display elements. So if you want to do something with a display element on the Arduino or whatever controller you're hooking it up to, then for the Arduino, the library allows you to just declare a function. And what I'm doing here is this is when I've moved a slider. And that is it. So you can see here, most of what is in here is actually not to do with driving the Nextion display. It's actually to do with the normal coding you would do with an Arduino or whatever other microcontroller. And the actual work of talking to the display is simply setting up the objects up the top here that you want to be able to communicate with on a display. And then initializing and attaching the event handlers and just writing the event handlers. And within the event handlers is more about the localized code that you want to do than it is about the display itself. Albeit there are some areas where I'm looping the data that's coming from the display back to other elements on the display. But that's it. So that's how easy it is to use a Nextion with an Arduino Uno, and that's a little bit of information about the Nextions that I hope will encourage you to at least have a closer look and try one out. As I said, they're not expensive. If I bring up the Nextion site, let's go have a look. So the expansion board is that board that I was just showing you with the buttons on here. And it looks like they got a buy one, get one free as well. So that's pretty cool. Anyway, let's go look at the displays that they have available and see how much they are. So there's a 2.4-inch one, so it's starting at $17 US. So here's the 17-inch one, $96 Canadian, but that's comparable with the Raspberry Pi displays. UK pounds, just over 50 pounds, or 74 US dollars. This is one with 108 megahertz CPU on it, and there it is at $71 US. So all in all, the amount of effort it saves you when you're trying to set up your application and things it's probably worth spending the $71. And you know, most of these companies, if you're buying bulk, will give you discounts and things like that as well. And right now they've got a order this product now and you get one free expansion board for each display you ordered. So that pretty much completes it. As I said, you get these little adapters with the little cable as well. So once you've actually set the display up, you can actually power it from a wall wart if you want to. It takes 5 volts to run it, and then the other 2 lines that are on here go to the microcontroller, whatever one you happen to be choosing to use. They all have as well on the back of them as an SD card so that you can plug your graphics in directly to the back of the card, or you can actually put your screen application onto the SD card as well and plug it directly in, and that gives you a much faster upload speed to get it up there. If you're actually trying to put a lot of graphics and things with your application and serially sending it up to the display, it can take quite a few minutes to upload it. But if you put it onto an SD card, it becomes significantly faster. Yes, so anyway, check them out. I hope you like this video. I hope you see how easy it is to interface. I will see you next Friday where we will review something else. Depends what comes in the mailbox. Bye.